Hey everyone, how are you? In this video, we are going to solve the Leetcode problem of the day, and the problem is find closest node to a given two nodes. The problem category is of medium level, but I would say once you watch this video, understand the problem and the solution approach, this is going to be really easy for you. In the problem, what's given is a directed graph which has n nodes. So there is a graph which is directed, which has n number of nodes, and let's call it as 0 to n minus 1. These are your nodes. Every node in your graph has at most one outgoing edge. So we know that in a graph, when there are multiple nodes, they are connected with edges, right? And since the graph is directed, the edges is one directional. You can only go from one node to other node. You cannot come back, right? And it says that each node has at most one outgoing edge. It means if you have a node and you have an edge, then it will have at most one edge. It will not have a multiple edge outgoing. It can have multiple incoming edges, but it will not have multiple outgoing edges. So at most one means it might have an outgoing edge or it may not have an outgoing edge, which means that if you have a node 0 and a node 1, and if you go from 0 to 1, this is your outgoing edge from 0 to 1. Now you will not have another outgoing edge from 0 to let's say 2. This is not possible because each node is going to have at most one outgoing edge. So there is a possibility that there is no outgoing edge from a node, but if there will be an outgoing edge, this will at most be 1. So this point basically means that if you go from one node to other node, you will just have one path. If you reach to the node 0, you can go to some other node and you will have just one path, maximum one path. Okay, we will understand more about this when we will see the examples. Let us for now focus on the input. The given input in the problem is an edges array of size n, and in this particular array, every element at index I is denoting the node where we can go from the node I. It means that we have an edges array which has size of n is the number of nodes we have in our graph, and for every node at index I, so basically the index is the node number, you can say, because the nodes are from 0 to n minus 1. So basically for every node, this edges of I is telling that which other node we can go from this node number I. And there is one more thing which is given, that the value of edges of I is going to be minus 1 if we cannot go anywhere from the node I. So if you have a node 0, and from 0 if we can go to 2, then at index number 0 in our edges array, the value is going to be 2. It means from 0 we can go to 2. That's the outgoing edge from 0. And there is a possibility that from 0 we cannot go anywhere. Might have many incoming edges but no outgoing edges. So at index number 0, the value is going to be minus 1, and that's what this point is telling us, that the edges of I is going to be minus 1 if we cannot go anywhere from the node I. Apart from the edges array, we are given two more input, which is node 1 and node 2. So we are given two more nodes, and what we need to find out as an output is the index of that node. So basically we need to find out the index of a node which can be reached from node 1 and node 2 both. So the point is, if you are given n number of nodes, then you will be given two other nodes as an input, node 1 and node 2, which are a part of these n nodes. Now you need to find out some node which can be reached from this node 1 and node 2, which is given in the input, and it can be reached from node 1 and node 2 both. That's the first point. Now the thing is, you need to find a node which is reachable from node 1 and node 2 both, and you need to make sure that the maximum of the distance from the node 1 to the node and the distance from node 2 to the node should be minimum. And this statement might be confusing, but let me explain you this. So let's say you have node 1 and node 2 as 0 and 1, and the common node you found which is reachable from both the nodes is 3. So you can reach from 0 to 3 and you can reach from 1 to 3, and let's say the number of edges or the distance between 0 to 3 is 4 and 1 to 3 is 5. And what you need to try now is, you need to first find out the maximum of the distances. The distance are 5 and 4 and the maximum value is 5. You need to minimize this value. So basically the chances are that when you have two nodes, node 1 and node 2, then there are multiple other nodes which are reachable from node 1 and node 2 both. You need to make sure that the maximum of the distance from node 1 to node and the node 2 to node, this value should be minimized. So if you have multiple nodes which are common, let's say A, B, C, these are the three nodes which are common, which can be reached from node 1 and node 2 both, then you first need to find out the maximum value of this, right? The distance from node 1 to A and node 2 to A. You need to find the maximum of it, and let's say the value is 4. Let's say for B the value is 3, and let's say for C the value is 4. In this case, you need to choose the minimum value. So B is going to be your answer, because you need to find out the index of the node, right? So you basically need to return that node which is reachable from node 1 and node 2 both, such that you minimize the maximum of the distance from node 1 to node and distance of node 2 to node. Now, if you are still confused about something, don't worry, we will understand everything in depth when we will understand it with examples, right? So for now, don't worry about anything. Now, you need to return minus 1 in that case if no such node exists. That is, for the given node 1 and node 2, we do not have any node which is common, which can be reached from node 1 and node 2 both. So in that case, you will return minus 1. Also, you need to return the lowest index node if we have multiple answers. For example, if there are three nodes A, B and C which can be reached from node 1 and node 2, and this value for all these three nodes are 3, 3 and 4. Now you need to choose the minimum, right? But we have two values which are minimum. For A it is 3, for B it is 3. So in that case, you need to return the lowest indexed node. So basically, if the value of A is less than B, you will return A. If the value of B is less than A, you will return B. Value means the node number, basically the index. One more thing you need to note is cycles might exist in the graph. So there is a possibility that if you can go from 0 to 4 and you can go from 4 to 0. So this is a cycle, right? From 0 you will reach 4, from 4 you will reach 0, then from 0 you will again go to 4, from 4 you will again go to 0. So this is a cycle, right? You cannot go anywhere in the graph if you reach to 0, or if you reach to 4, you will be stuck in this cycle, because we know that there is just one outgoing edge. There is at most one outgoing edge, so we will not have any other edge, so no other path, right? Now let us try to understand about this using the example. So let us say the given edges array is 2, 2, 3, minus 1. So basically we have 4 nodes in this particular example. Node 0, node 1, node 2, node 3. These are the 4 nodes which we have. From node 0 we can go to 2. From node 1 we can go to 2. From node 2 we can go to 3. And from node 3 is minus 1. It means from node 3 we do not have any outgoing edge. We cannot go anywhere if we reach this node 3. So basically the graph will look something like this. This is 0, this is 1, this is 2, this is 3. So from 0 to 2, then we can reach from 1 to 2, then we can reach from 2 to 3, and then we cannot go anywhere from 3, so it is minus 1, right? So this is our graph. Now we are given two nodes. Node 1 is 0, node 2 is 1. So we are given these two nodes, node 0 and node 1. What you need to find out is a common node, the index of that node, which can be reached from node 1 and node 2 both. Now I will come to this point, but for now let us try to find out what are the common nodes which we can reach from 0 and from 1. So from 0 I can go to 2, right? And then I can also go to 3, right? So there is a path from 0 to 2 and 0 to 3. There is no path from 0 to 1, right? So from 0 I can go to 0, 2 and 3. Basically from 0 I can be at 0, right? So I can go to 0 as well. And from 1 what I can do is, from 1 I can go to 1, then I can go to 2, then I can go to 3, right? So there is a path from 1 to 2 and 3. So for 1 it will be 1, 2, 3. Now what are the common nodes where you can go from node 1 0 and node 2 1? So the common nodes are 2 and 3, right? So these are the common nodes you can reach from 0 and 1. So the common nodes are 2, 3. Now we can come to the next point, which is what is the maximum of distance from node 1 to node and distance of node 2 to node. So try to find out the distance from node 1 to the node and node 2 to the node. So the distance from 0 to 2 and 1 to 2 is 1, right? And if the node is 3, this is also another common node, right? So from 0 to 3, the distance is 2. You will have to travel 1 and then 2 edges. And for 1 to 3, the distance is 2. You will have to travel 2 edges. So now this is the value. What is the maximum out of it? It is 1 and it is 2. So this is what we just found. We found the maximum of the distance from node 1 to node and the distance of node 2 to node. And now we need to minimize the values. So these are the distances we found. 1 is the maximum distance from both the nodes to 2, and 2 is the maximum distance from both the nodes to 3. The minimum out of it is 1, which is for 2. The answer or the output in this case is going to be 2, because we need to find out that particular node index which has the minimum distance. Let us see another example in which there is a possibility of a cycle. In the example number 2, the edges given are 4, 4, 4, 5, 1, 2, 2. So basically the nodes are 0, 1, 2, 3, 4, 5 and 6. So we have total 7 number of nodes, right, which are numbered from 0 to n minus 1, which is 0 to 6. Now from 0 I can go to 4, from 1 I can go to 4, from 2 I can go to 4, right? So 0 to 4, 1 to 4 and 2 to 4. Then from 3 we can go to 5. So from 3 we can go to 5. So from 4 we can go to 1. So from 4, okay, this is wrong. We just need to delete this and make it from 4 we can go to 1, right? So from 4 we can go to 1. From 5 we can go to 2. And from 6 we can go to 2. So now our graph will look something like this. Now let us take two different examples. When the node 1 and node 2 is 1 and 1 and 3 and 6, we are going to process both these inputs separately for the same edges. Now, first of all, you need to understand that if you try to find out which common nodes I can go from 1 and 1. So from 1 I can go to 4, and from 1 I can go to 1 as well, right? Now the thing is, what you need to focus right now is, if we start from 1, we can go to 4, 4 can come back to 1, and then we can again go to 4, we can again come back to 1. So basically this is a scenario of a cycle, right? We have a cycle right now. So this is one of the case in which we can have a cycle. We need to handle this case. So when we will see the solution approach, we will see how to handle this particular cycle approach. For now, what you need to focus on is what are the common nodes we can go from node 1 and node 2. So what you can do is, you can say, okay, from this one I can go to 1 and I can go to 4. From this one I can go to 1 and I can go to 4, right? Now if I want to reach to 1, the maximum distances will be 0. If I want to go to 4, the maximum distances are going to be 1. What is the minimum out of it? It is 0, which is for node 1. So the answer, if the node 1 and node 2 is 1, will be, output will be 1. This is the common node where you can go from node 1 and node 2. Now what about if the value of node 1 and node 2 is 3 and 6? So from 3 you can go to 3, then 5, then 2, then you can go to 4. From 4 you can go to 1. Now this is going to be circular. 1 will be back to 4, 4 will be back to 1. So you don't need to process further. These are the different nodes you can reach from 3. So let's make a note out of it. 3, 5, 2, 4 and 1. These are the different nodes, right? What about 6? From 6 you can go to 6, you can go to 2, you can go to 4, you can go to 1. So for 6 the nodes are 6, 2, 4 and 1. Now what are the common nodes? The common nodes are 2, then we have 4, then we have 1. These are the three common nodes between our node 1 and node 2. So it is 2, 4, 1 which are common nodes. Let us see the distances of 2, 4, 1 from 3 and from 6. So from 3 the distance of 2 is going to be 1 and 2. So this will be 2. From 3 the distance of 4 is going to be 3 and distance of 1 is going to be 4. Because this is 1, then 2 and then 3 for 4, then 4 for 1. Right? So these are the different distances you can go from 3 to 2, 4 and 1. Now what about 6? What is the distance from 6 to 2, 6 to 4 and 6 to 1? So the distances are 1, then 2, then 3, right? So this is going to be 1, 2 and 3. Now you need to find out the maximum out of these values. 2 and 1, 3 and 2, 4 and 3. So the maximum are 2, 3 and 4. Now you need to minimize the value. So the minimum is 2 which is for the node 2, right? So what we can say is this node 2 is going to be the output when these are the edges and these are the nodes. So node 2 is going to be a common node which can be reached from 3 and 6. Now let us see the solution approach. So in the solution approach, let us consider the example number 1 where the edges given are 2, 2, 3, minus 1. So the nodes are 0, 1, 2 and 3 and this is how the graph will look like. You can go from 0 to 2, then you have 1 to 2, then you have 2 to 3 and then from 3 you cannot go anywhere, so the value is minus 1. So this is our graph and the given nodes are 0 and 1. So these are the two nodes for which we need to do the processing. Okay, let us do one thing. Let us find out what are the different nodes we can reach from 0 and we can reach from 1. See, the thing is what we need to do is we need to do two things. We need to find a node which can be reached from both the nodes and the maximum of the distance from node 1 to node and distance of node 2 to node should be minimum, right? So let us try to first find out what are the common nodes which can be reached from both the nodes and we need to make a note of the distances as well so that we can apply it in this particular formula. So let us do it. Let us come back to the solution approach. Now what you need to do is you need to say for 0 which is the node 1, can I go to 0, can I go to 1, can I go to 2 and can I go to 3? And if I can go, then what are the distances? So from 0 I can go to 0 without traveling, right? So the distance is going to be 0. From 0 can I go to 1? So in the graph I cannot see any path so that from 0 I can go to 1. From 0 I can go to 2, from 2 I can go to 3, from 3 I cannot go anywhere, so I cannot go to 1, right? So I can say from 0 I cannot go to 1, so the value is minus 1. From 0 I can go to 2 by traveling 1 distance. From 0 I can go to 3 by traveling 2 distance. So basically from 0 to 2 you need to travel 1 edge, but if you want to go from 0 to 3 then 1 and 2 you will have to travel 2 edges. So now you have this particular array which is telling me that from 0 I can go to 0, I can go to 2, I can go to 3. This minus 1 is telling that I cannot go to 1. So now I have a note of what are the different nodes I can reach from node 1 and what are the different distances. The same thing we need to do for the node 2 as well, which is 1. So from 1 I cannot go to 0, so this value is minus 1. From 1 I can go to 1, so the value is 0 because we don't need to travel. From 1 I can go to 2 by traveling 1 distance, and from 1 I can go to 3 by traveling total 2 distance. So for 1 at index number 2 the value is 1, at index number 3 the value is 2. Now once you have this traversal array created, you can find the answer very easily. First of all, you need to find out what are the common nodes which can be reached from 0 and from 1 both. So the node will be common if none of the values are minus 1. If this is minus 1, it is telling me that from 1 I cannot go to 0. So this cannot be a common node, right? So let us check for 1. Is this a common node? No, it is not a common node which can be reached from 0 to and 1 because this is minus 1, which is telling me that from 0 I cannot go to minus 1. Is 2 a common node? Yes, it is, because the values are 1 and 1. None of this is minus 1. It means that from 0 I can go to 2, from 1 I can go to 2, and the distances are 1 and 1. What is the maximum out of it? The maximum is 1. Similarly, for 3, can we go to 3 from 0 and 1? Yes, we can go. Because the distances are 2 and 2, none of them are minus 1. It means from 0 and from 1, I can go to 3. What is the maximum of the distances? It is 2, right? Now, these are the different maximum distances we have if we want to go from 0 and 1 to 2 and 3. What is the minimum out of it? It is 1, which is for node number 2. So basically, we will keep track of the minimum value and the node as well. And the minimum value is 1, the node is 2. We just need to return the node index. So the output is going to be this particular 2. This is our output. So basically, the main approach or the main thing is how can we create this traversal array? And this is very simple, guys. Let me show you how can we do it for this node 1, and the process is going to be similar for node 2. First of all, you can create an array of size n, 0, 1, 2, 3. These are the different indexes, and keep all the values as minus 1. So this is saying that none of these nodes are reachable from the node 0, or basically whatever the input is given, node 1 or node 2. Now let us say you start from the node which is 0. This is node 1. So the starting node is 0. From 0 you can go to 0, right? So the distance from 0 to 0 is going to be 0. This is the starting phase. This is where you will start your traversal. So you start at node 0. You can go to node 0. So this value is going to be 0. So now the traversal array is 0, -1, -1, -1. Now once you are at 0, you will check your edges array. Can you go from 0 to anywhere? Yes, you can go to node 2. So from 0, I can go to node 2. So I will say now my starting point is changed. It is edges of start. This is my previous edge start. This value is 0. So edges of 0 is 2. So now from 0, I can go to 2 and the total distance is going to be increased by 1. So this is going to be 1. So now at node 2, it is going to be 1. Now tell me, if my start is 2, then the edges of start, what is the value of edges of start? It is 3. It means from 2, I can go to 3. And now my distance was 1. The new distance is going to be 1 more, which is 2. Because we are actually trying to find out what will be the distance from 0 or from the given node 1 to the node 3. So the distance is going to be 2 increased by 1. So the value for node 3 will be 2 in the traversal array. Now you need to find out edges of start. The start is 3 right now because we are at 3. Now in the input, edges of start is given as -1, which is telling me that I cannot go anywhere. So you will stop here. So you are not going to update anything in your array. This is the final array which you have created. 0, -1, 1 and 2. And that's what we have. 0, -1, 1 and 2. So this is how you create your traversal array, guys. And there is just one more thing to understand right now, which is how to avoid any cycle. See, the thing is, you only update when the distance of the node is -1. That is, let us say you start from 0, you reach to 0. So this particular array will now be updated, and for 0 the value is 0. This is the distance. You will update this value only when it was -1 previously. Now this is 0 right now, okay? Now let us say from 0 you go to 4, you go to 8, you go to 10, and then from 10 you go to 0. If from 10 your new starting is 0 again, and you are trying to update the value of 0 again, right? The node 0. So you will not do it, because right now it is not -1. If it is not -1, it means that we already have a path so that we can reach to 0. If you are coming back to 0 again, then we will not update this value. It means we have a cycle and we can stop there, right? So this is how you can avoid the cycle. You just need to update the value of your distance or your traversal array only when for your traversal array for a given node the value is -1. If it is not -1, do not do an update and stop there because you have got a cycle. So that's the complete explanation of this particular problem and the solution approach, guys. Let me take you back to the code editor and let me show you how the code of this particular problem will look like. So this is the complete code for this particular problem. First of all, we will find out how many nodes we have. So n is equal to the length of your edges. Then we have created this DFS function. We will come to this. What you need to do is you first need to create your traversal array, right? So node 1D is for the first node, the traversal array for the first node. Node 2D is the traversal array for the second node. You will create the traversal array using the DFS function where you are going to pass your starting node, which is node 1, and for this it is node 2, and the distance. So for the starting node, the distance is going to be 0. Now let us understand this particular function. What we did is we created a distance array which is of size n with all values as -1, and then we run a loop that if the starting value is not -1, that is, we have not reached to a node which doesn't have an outgoing edge, and the distance of the current starting node is equal to -1. So basically we are checking that from our current node we can go to some other node and the distance for our current node is -1. If it is -1, then we will update it. So what we are going to do is we are going to say the distance for our current node start is going to be the distance, which is for now 0. And then we will increase the value of distance by 1 and we will update the value of start, which is going to be coming from the edges array, edges of start. And then once with this particular loop ends, we will return this distance array because this is our traversal array. So once the traversal array is created, what we can do is we can create a value min distance, which is for now infinite, and then answer, which is the output we need to give, which is -1 for now. Then run a loop for n times and check that in the traversal array for the current node, the value should not be -1. If it is not -1 for both the traversal arrays, it means that we can reach to this particular node I from both the nodes, node 1 and node 2. If we can reach to that distance, find out what is the maximum distance. The maximum distance is going to be the max of node 1D. That is the ith value of the first traversal array and the ith value of the second traversal array. Just find out the maximum out of it and check that if this maximum distance is less than what we have already got. So initially the minimum distance is going to be infinite, but later on it will get updated. So we will say if the max distance is less than the min distance is going to be updated, and the answer, that is the common node, is going to be updated as I, because this is our node. After this loop will end, we will just return the value of the answer, and that is going to be the complete code for this particular problem. So let me maximize this so that you can see the complete code. So this is the complete code. Now you can submit this and this will be accepted, and the runtime and the memory both will be good. So yes, you can see the runtime is good, the memory is good. So we have solved this particular problem. So I think that's it for this video, guys. If this video helps you to understand the problem and the solution approach as well, then make sure that you like the video. And if you have not subscribed to my channel as of now, then make sure that you subscribe to the channel as well. And I will see you guys in the next video. Thank you for watching this video, guys.